about scientific notation. So scientific notation is a way of representing very, very big or small numbers, typically, using exponents. So let's look at an example here. So if I gave you the number 312, let's say billion. This is a pretty big number, right? So this number would be a pain to like write out all the time. It would be a pain to do calculations with if you're trying to enter it into a calculator or something. And this, as far as some numbers we work with in science, is actually on the smaller side. You can end up with things with many, many, many more zeros than you have here. And if you think about this, a more compact way to represent it is one thing that might jump out at you is this is just some number multiplied by 10 several times, right? This is just like 312 multiplied by 10 9 times. And so because of this, what we were able to do is kind of compactify this and say, well, for convenience, let's always, for scientific notation, let's always take a number here that is going to be between 1 and 10, some number. I don't know why I put this up here. So between 1 and 10. And we're going to multiply that by 10 to some exponent. Okay. So if I look at this, I say, well, I can take 3.12, that's a number between 1 and 10, and say how many times do I have to multiply this number by 10 to get this number up here? And you just count, right? So if I have a decimal here. If I move it over here instead, I would say I have to multiply it by 10 once, I get 31. Twice, I get 312. 3 times, I get 3,120. 4, 5, 6, 7, 8, 9, 10, 11, right? So this number is 3.12 times 10 to the 11th power. To be clear, we didn't change the value of this number at all, right? This is the same number as the number up here. The only thing that's different is the kind of format in which we've written it. This format is called scientific notation. Okay, and again, it will always be number times 10 to an exponent, where the number is going to be between 1 and 10. So you'll never want to have 10 times 10 to something, or 11 times 10 to something. And you also don't want to have something like 0.2 times 10 to something. You always want to have 1 point something, 2 point something, 9 point something, whatever. Okay, but you can also go the other way, because this is a really big number with lots of zeros. But really small numbers can also have lots of zeros, right? Suppose instead I gave you this number. Let's say we did 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 3, 12. I could represent this with scientific notation as well. Because again, I could say, well, it's going to be 3.12 times 10. But when we multiply it by an exponent, right, we're not really multiplying by 10 here. If I'm starting with 3.12, multiplying by 10 makes me bigger. So I'm really dividing by 10, okay? But division by 10, we said earlier, if we had a negative exponent, if I have, 10 to the negative 1, this is the same thing as 1/10. So this means I can actually represent divisions with exponents as well. So I'm going to do times 10 to a negative exponent, because I want to end up with a number that is smaller than the 3.12. So I say, okay, well, if I take 3.12 and divide it by 10, I get 0.312. So then I have to just count how many times am I dividing by 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Negative 14, okay? Be careful to not just count zeros here, okay? If you count zeros here, you're going to get the wrong answer, because by convention we like to put a 0 before the decimal point, because otherwise it's easy for people to kind of miss that there's a decimal there. So you actually want to go through and count, how many times are you moving the decimal point, not how many times, how many zeros are there. Okay. So now what I'm going to do is I'm going to put up a couple of problems here. I'm going to say I want you to convert from standard notation, which is just numbers, standard notation, to scientific notation instead. So I'll give you 4 problems here. We'll say 3, 6, 7, 1, 2, 3, 4, 5. That number, this number, this number, and this number. So pause the video, take your time, try to convert each of these 4 numbers into scientific notation. So number between 1 and 10 times 10 to some exponent, okay? So this first one here, I'm gonna first identify what number I want to multiply. It's gonna be 3.67, right? You could really do that for each of these. I'll change colors so that the answers are clearer here. Let's use this. So 3.67. Right? I can do that for all these. I know I'm going to want this to be 6.9, you know, whatever. So 3.67, how many times do I have to multiply this by 10 to get the number of zeros that I get? Well, if I start with a decimal here, I have to multiply by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So 3.67 times 10 to the 11th power. That's my scientific notation, right? And remember, if you're more comfortable going the other way, you can check your answer after. If I'm doing 3.6 times 10 to the 11th, just, you know, move the decimal 11 spots to the right and check, okay? Because that's how we go the other direction, right? Is we just actually multiply by 10 that many times. Every multiplication by 10 moves the decimal 1 to the right. Every division by 10 moves the decimal 1 to the left. Over here, 6.9, this is going to be times 10 to the, and we count 1, 2, 3. So times 10 to the 3rd power. Okay. Now let's move on to the ones that are smaller. So here, this one is going to be 2 times 10 to the, and I count. So I want the decimal here. The decimal started here, right? So I'm going to say, okay, 1, 2, 3, 4, 5, 6. So it's going to be 6, but because we're getting smaller, we're dividing, right? So we really want this in the denominator. So it's going to be negative 6 as our exponent. And the last one here, don't let the negative sign up front throw you off. It doesn't change anything. I'm just going to write this as negative 1.41 times 10 to the, and I'm going to do the exact same process, okay? You can use scientific notation with positive or negative numbers. It doesn't matter. It works with both of them. So as we did before, we want the decimal here. So we say, okay, this is going to be how many times? If I'm starting with like negative 1.41 and I'm dividing by 10, every division by 10 moves me 1 left, right? So 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Okay, that's it. Let's also try going the other direction. So let's say I want to convert from, we'll say from scientific to standard notation. Okay, so let's say, I'll give you a couple. 9.6 times 10 to the 6th. We'll do negative 2.4 times 10 to the 3rd. We'll do 2.6 times 10 to the negative 1. And 1.814 times 10 to the negative 8. So again, pause the video here and go ahead and try to do each of these 4 problems, and then you can resume and see how you did. So this first one, right, I am multiplying by 10 6 times. That's what it means to have an exponent, right? This is 10 times 10 times 10 times 10 times 10 times 10. So I'm going to go and say, okay, so we're going to move the decimal point 1, 2, 3, 4, 5, 6. And basically just fill in the empty spots with zeros, right? Every time I multiply by 10, 9.6 times 10 to the 1 is 96. Times 10 to the 2, that's saying 9.6 times 100 is 960, right? Times 1,000 gives me 9,600, 10,000, 96,000, and so on until we end up where we want, right? So this is my standard notation answer here. This one, negative 2.4 times 10 to the 3rd. Again, the negative sign out front here doesn't affect anything. You would just keep your answer negative. So it's going to be negative 2, and then we want to move the decimal point 3 spots, right? So 1, 2, 3. Negative 2,400, right? After you do this, as long as your exponent is positive here, right? This is positive, you should end up with a number that has a larger absolute value, right? So 2,400 is bigger than 2.4. 96, big number, is bigger than 9.6, right? Down here, these are being raised to negative exponents, which means the number should shrink, right? We should end up with a decimal because we're dividing by 10 a bunch, right? So this first one, 2.6, we're multiplying by 10 to the negative 1. But 10 to the negative 1 is just 1/10. So I'm basically just dividing this by 10. So I move it one spot over. So I'm going to get 0.26. And remember, we're just added the 0 here because it's like nice to put a 0 in front of your decimals. It's not wrong if you just write 0.26, but like put the 0 there. And then we have this one, right? So I have 1,814. And we're moving the decimal point 8 spots to the left, because if I divide by 10 once, I'm here. So we go 1, 2, 3, 4, 5, 6, 7, 8. So decimal point is here. So I'm going to put 1 0 before it, and then I'll fill in all the other spots here with zeros. That would be my answer for that one. Okay. So that's scientific notation. So that brings us about to the end of exponents. Might do like one more thing, but we're also going to be moving on next to logarithms, which are kind of whereas roots undo the powers of exponents, logarithms undo the base of exponents. So it's going to be a cool thing. That's what we'll look at next.